Today we're going to be looking at section 5.6 part 1. We're going to be talking about inverses. So on this first part it says to make tables of values for the input and outputs that are shown. It shouldn't say makes, it should say make. So an inverse, the definition of an inverse is that it is a relation that undoes the action of another relation. So if you look at this function right here, this is our function f. A goes to 3, B goes to 1, C goes to 2. So my table of values right here, this is going to be inputs, this is going to be outputs. So for my function f, my input A goes to an output of 3, input B goes to output of 1, input C goes to output of 2. So now we're going to look at this. This says f to the negative 1. F to the negative 1 is another name for inverse. And we're going to look at these inputs and these outputs. So if our input is 1, our output is B. If our input is 2, our output is C. If our input is 3, our output is A. Look at this. A goes to 3, 3 goes to A. B goes to 1, 1 goes to B. C goes to 2, 2 goes to C. This is called an inverse when this happens, when the inputs and the outputs completely switch. Also can be thought of, our domain and ranges completely switch. It's like they're undoing one another. So the notation for the inverse of f of x is f to the negative 1 of x. All right, we're going to look at this now. Make a table of values for f and for the inverse of f. So finding an inverse graphically. If we have the graph of f of x, we can take any xy and form the point yx. This new point is a point on the inverse function. So let's take some points we can see. I'm first going to look at the f function. So I'm going to put that in purple so we can see it better. So there's our f function. So just taking a few points. So let's look at this point here. So we're going to compare x and f of x. So this point right here would be negative 2, 2, negative 2, negative 2. This point right here would be 0, negative 1. And let's take this point right here. This point looks like it's about 1, 0. All right, so now let's look at the points on the inverse function. So on the inverse function, looking in that same kind of area, here's our inverse function. We have this point right here. That's still negative 2, negative 2. But on the inverse function, we have this point right here. And that is about negative 1, 0. It's not exactly right on there, but the other one wasn't either. Just trying to get close to it. And then I also have this point right here. This is 0, 1. Can you see this comparison? 1, 0, 0, 1. 0, negative 1, negative 1, 0. Negative 2, negative 2. It's hard to see much from that. But what I want you to see is how the inverse of the function is a reflection over that line y equals x. So if I start with this purple function and I reflect it over the line y equals x, I would get that function that's in black. And that's another way to show that functions are inverses. And that's because x is becoming y is becoming x. In this part, determine whether each pair of functions f and g are inverses. So if I look at my inputs, they should now become my outputs. And they did. Looking at the outputs, they should become the inputs, and they did. So yes, these are inverses. Looking at the inputs, they should become outputs. Looking at the outputs, they should become inputs. They did not. So this is no. Now we're going to use the chart. What is f of negative 2? I'm going to look at my f function. F of negative 2 is 9. What is g of 9? Looking at my g function, when I have an x value of 9, g of 9 is negative 2. See the relationship? Negative 2, 9, 9, negative 2. What is f of 1? And we're talking about number 3 here. So looking at 1, I get negative 3. That's the y value when x is 1. what is the y value for the g function when x is negative 3? And it's 1. Again, that relationship, 1, negative 3, 1. That's how we can tell their inverses. Graph the inverse for each of the following, keeping in mind that x becomes y and y becomes x. State whether the original is a function, then state whether the inverse is a function. All right, well, this is a linear function. It's a function because it passes that vertical line test. A vertical line only touches it at one spot, so yes, it is a function. I can take some points. This point right here is 0, 3. So my new point is going to have to be 3, 0. Look at another point. Right here I have the point 2, 2. My new point would have to be 2, 2. Here I've got the point 4, 1. My new point would have to be 1, 4. All right, so then connecting those, I can graph the inverse function. So right here's the inverse function. And can you see how if I take this line y equals x, which has a y-intercept of 0 and a slope of 1, see how this line y equals x fits right through there. Those inverses, right there, those inverses are a reflection over that line, y equals x. All right, looking at this one, just finding some points. I've got the point 0, 0. I'm still going to have the point 0, 0. I've got this point 1, negative 1. Now I'm going to have the point negative 1, 1. On my other one, I have, right here I have the point negative 1, 1. So my new point is going to be 1, negative 1.
With Jalen Bronson, please report to the main office, please. Jalen Bronson.
All right, so this is going to keep going on down here, and it looks about like if it kept going that I would have the point 2, probably negative 6. So now I'm going to have the point negative 6, 2. Right about there. Looking at this point, it looks like it's about negative 2, 6. So now I'm going to have the point 6, negative 2. And so here's the way this new function is going to look, the inverse function. And again, I'm keeping in mind that it should be this reflection over this line y equals x. So there's how the inverses would look. All right, let's do this one. I have the point 0, negative 1. Now I'm going to have the point negative 1, 0. I've got the point 1, 0. Now I'm going to have the point 0, 1. I have the point 2, 3. So now I'm going to have the point 3, 2. This point right here is going to be negative 2, 3. So now I'm going to have the point 3, negative 2. And let's see, right here, this point right here, rather, is going to be negative 1, 0. Now I'm going to have 0, negative 1. Okay, back to the original being a function and the inverse. Back here, they were both yes for both. The original was a function and the inverse was a function. Here, the original, yes, is a function, inverse in purple. It passes the vertical line test. So yes, the inverse was also a function. But here, when I graph this inverse, here's the way it's going to look. So is the original a function? Yes. But look at that inverse. Is that inverse a function? No, it's not, because it does not pass the vertical line test. All right? How do we find inverses of functions? Well, first we write f of x as y. Then we change any x to y and change any y to x. That's what an inverse does. They switch. Solve for this new y. Then replace the y with f to the negative 1 of x. On the Big Ideas website, or when you take, do your Big Ideas assignment, they're going to call the inverse just g of x. We're going to call it this. This is the more mathematically correct name for it. And so that's what this is saying. So we're going to be using that notation. All right, we're going to find this inverse. So So we start with f of x. I'm going to change it to y. That's another name for f of x. Now y becomes x becomes y. Solve for the new y. Subtract x. Divide by -2. All right, so now I'm going to kind of switch it around. These cancel, so I have y equals x minus 3 all over -2. But now I'm supposed to give this its name. On Big Ideas, they're going to call it g of x. And let's go ahead and divide each of these terms by -2. So I'm going to have -1/2 x plus 3 halves. That's the way Big Ideas is going to write it. We are going to write it like this. Meaning that instead of using g of x, we're going to use the inverse of f of x. That would be our inverse. If you wanted to check it, a really nice way to quickly check to see if they're inverses is to look at them on the calculator. See how they appear. Do they appear to be inverses? Do they appear to be reflections over that line y equals x? I might even want to put in y equals x just to see. And I'm going to do a zoom square. That makes my screen so that it looks more like a square instead of a rectangle like usual. And there are the two that I came up with, and there's y equals x. They do appear to be reflections over that line y equals x. I could look at my table of values. All right? Looking at this point, -2, 7. I should see the point 7, -2, and I do. Look at this one, 0, 3. I should see the point 3, 0. So that's another way to support the fact that I did that correctly. All right, here's f of x. That's just y. Y becomes x becomes y. Solving for this new y, I have to get rid of the negative first. So now I'm going to have -x equals y cubed. I'm going to go ahead and switch these around this way. I'm allowed to do that. To get rid of the y cubed, I have to do the cube root of y on both sides. So now I'm going to have y equals the cube root of -x. So, rewriting that, Big Ideas, you'll write it this way. For us, you'll write it this way. You want to check it out? Not sure it's right? Do a quick check of it. Put in -x cubed and put in math cube root of -x. Graph it. Take a look at it. -x to the third looks like that. Here comes the cube root of -x. Looks like this. Looks pretty good, doesn't it? Here comes y equals x, right down through there. If I look at my table of values, I should test some points. I see -2, 8. Do I see 8, -2? Yep, we're good. All right, one more here. This is f of x. That's another name for y. So I'm going to rewrite that f of x as y to start with. Y becomes x. X becomes y. I would like to go ahead and eliminate these fractions so I can multiply through by the common denominator. That's going to be 10. So multiply everywhere by 10. Multiply that by 10, you get 10x. This multiplied by 10. 10 divided by 5 is 2 times 4. Half of 10 is 5. Want to solve for this y. So I'm going to have -8y equals 10x minus 5. I'm going to switch it around now. I always want my y on the left, just easier to work with. Divide by -8. Every term gets divided. That reduces to -5/4 x plus 5/8. So on Big Ideas, they're going to call that g of x. We're going to call it the inverse. There we go. If you wanted to check it on the calculator, you could, but there's our inverse. All right? That's it for 5-6 part 1, and then we'll talk about some more complicated inverses on the next time.